I've been showing you this in one dimension. It extends pretty simply in two dimensions. And here are the two-dimensional forms, okay? So this f of u, this is just when I've got a continuous two-dimensional function. Here we have f of xy. Well, when we do it in discrete land, f of xy is now going to be at discrete points. And then we have f of kx, ky, those are the two different frequencies. The discrete frequency in x, the discrete frequency in y. And by the way, this works in the middle. If you put the origin of k in the middle, you want to put the 0 in the middle, so from minus k, n over 2 to plus n over 2. Let's take a look at applying this two-dimensional discrete Fourier transform to images. So remember, we talked about that we're going to have these bases that have horizontal and vertical components and can be combined. What does that look like when we apply these things to images? So let's take a look at some very simple examples. All right, so here I have a sinusoid, and it's at some particular frequency, and it's only made up of vertical stripes. What is the spectrum, the power spectrum of its Fourier transform look like? Well, it looks just like this, and it's a little hard for you to see, but there are two bright dots there. The origin is here in the middle, and there's a dot to the left and a dot to the right. Okay, those are my spikes for the frequency of this particular sinusoid. So this picture, you see, has only horizontal stripes, and it varies more quickly. So these dots are now spaced vertically for a sinusoid that goes in this direction, and they're further out because the frequency component is higher. If I have a sinusoid in an oriented direction, same deal again. It's a little hard to see. We've got these dots that are spread in that direction. Let's go back to our linearity. So let's suppose I take the picture on the left and the picture in the middle, and I sum them together. And we're actually going to do a sum, so it's linear, right? So this picture is going to look like that. So, you know, it's some combination of sinusoids. But remember, a Fourier transform, a Fourier series, is just made up of sums and multiplies. It's a linear operation, okay? So the Fourier transform of the sum is just the sum of the Fourier transforms, okay? So that's why this picture is just these combined.